All right, so what I want to talk about is UV workflows for common geometric objects. So what does that mean exactly? When you have a common geometric surface or structure, there's a certain way you can approach it to recreate that design. So what we're going to do in this is several practice exercises where we get rid of the default UVs from existing objects and we recreate them using the tools we looked at previously. So let's go ahead and start off by just talking about the basic shapes we're going to be dealing with here. One of the first shapes we're going to be looking at is going to be the cube or rectangle shape, which can also be referred to as a six-sided shape. So when we talk about a six-sided shape, what we're dealing with is an object that has six planar surfaces. So a cube or any sort of rectangular surface. But this can expand to other things. For example, our desk. If you think about our desk is largely an elongated cube. It has a bit more complexity to it because it's actually a cube made out of cubes. So this approach we can use heavily for this. But it could be even more complex things, like if you had something like the arm of a mech style character, maybe it has this sort of boxy structure to it. And this boxy structure is also essentially a six-sided object. So to create a six-sided object, we're going to come in here and go to Create, Polygon Primitives, and Cube. And you will see over here in the UVs, we have 1, 2, 3, 4, 5, 6 planar faces that make up this object. Now, you can delete an object's UVs, and sometimes you might want to do this because there's a dozen different ways we can unfold a box. To do this, we're going to come under the Edit menu in the UV editor here, and we're going to delete. So we can go to Edit, Delete, and you'll see that we'll get rid of these UVs. When dealing with a six-sided object like this, you can come under the Create menu, and an automatic projection almost always is going to give you the result you want. So if you just click Automatic, what you're going to see is our end result is going to be 1, 2, 3, 4, 5, 6 planar surfaces that perfectly map the surface of the cube there and do so in a way that would make it very easy for us to texture. If we want to put these back together in some form of an assembly, there's a lot of different ways we could do that. We could use the Move and Sew tool. The way I would do that is I'd find an edge, usually in the 3D view, that I like. So for example, maybe I want these center edges to be welded. I could select that edge and go to Cut and Sew and do a Move and Sew on that to combine those. I can then work my way to the next edge here. Notice I'm selecting in 3D, come up here to Cut, Move, and Sew, and it sews them in 2D. And then I can do the same here, Cut, Move, and Sew. But inevitably, we do need to have at least one cut along this row. But we could come into the sides here now, and we could weld these together. So I could take this, for example, and do a Cut, Move, and Sew. I could do this, and we could do a Cut, Move, and Sew. And just like that, we've recreated the UVs for this box. So you can see without having to do any crazy work, we can recreate this fairly easily. Now, this is a geometric primitive, but if it did have more complexity to it, it still would be just as easy, or maybe only take a few extra steps. And we'll actually see that when we get into doing the UVs for most of our desk objects. From here, we could do a modify layout, and we'll now have that laid out. Okay? So when it comes to a cube, rectangle, or six-sided object, this is where that automatic is going to come in handy, and it's going to really do the trick for us. There's not much more we need to do. Now, the next one is going to be cylindrical objects, and cylindrical objects are going to require a few extra steps. When we describe a cylindrical object, what we end up with is basically a flat circular top, a flat circular bottom, and a stretched out midsection. And cylindrical objects are very common. If you think of something like an organic character's arm, this is generally going to be like a cylinder, if we think about this coming down. And even if you get down to something like the fingers of a character are going to be cylindrical. As a matter of fact, you can break down shapes, and if we think of something like a hand, you can think of a hand a bit like a box shape for the palm, and then a series of cylinders for the fingers themselves. And this can be a drawing tip as well. I'm not going to do a beautiful drawing here because I just want to speed through this. And I think this thumb's on the wrong side, but you can see how we could think of it in this sort of approach, which can allow us to break this down a little bit better. So let's go ahead and come here to Create, Polygon Primitives, Cylinder. And you'll see that is indeed what we have. We have a flat top, we have a flat bottom, and then in the midsection here, we have a unfolded or unraveled rectangle. Okay, so how are we going to create that? Well, the way I approach this is, first off, let's delete these. We need a projection. And instinctively, you might be thinking, oh, we're going to use the cylindrical projection. But if we do that, you'll see we have a bit of an issue. I'll come to cylindrical here. And you'll see that we get these weird little edges at the top here. And what's happening there with the cylindrical projection is it's doing a good job on this midsection. But those flat tops we need, well, they're flat, but they're not the kind of flat we can use. So they're so flat, they're actually, I guess you could say, one-dimensional. They're overlapping each other. Now, we could fix this a little bit by doing something like a modify unfold, and you'll see we get this jumbled mess. And this is pretty far from what we're looking for. Now, this is where using these projection tools in segments comes in, and using them for the appropriate task. In the past, we would use several different selections to create this. But what I like to do is I like to backpedal here and just think, oh, what do I need here? I need the top cut, I need the bottom cut, and I need a line down the middle. Well, if I can think in that, I don't need to think I need this type of projection and this type of projection, this type of projection. I can think I need a cut here, I need a cut here, and I need a cut here. And that's a lot easier. So instead, what I'm going to do is come here to create and do a camera-based projection. What this will do is it will give me all of our UVs captured in UV space. So there's no gaps, there's no cuts. And I can manually come in here now and cut these the way I want. So for example, I can come into edge mode, double click the top portion here and come to cut and cut. And I could do the same for the bottom. I could double click the edge portion here. I could cut to cut and cut. Now from here, if I do a modify unfold, you'll see that those top sections unfold nicely, but the midsection is this wild looking donut. What I can do there is I could do one cut down the middle, cut, and then we can come in here and do a modify unfold. And there we go. You can see we have now recreated this. You'll notice that it's a little bit lopsided. So to fix that, I could rotate this and get this into place. If you get it close, but you're having a hard time kind of teeter-tottering here, with this selected, you could do a modify straighten UVs, and that will straighten those. And then you could come in here and do a modify layout. And just like that, you've created a nice layout for these. One that's actually better than the default layout for the cylinder, which is worth noting, because remember when we created that robot, we had a lot of stretching, we had a lot of compression. This will actually take care of all of that, and we get a great end result. Now, with that said, there are some exceptions to the rules. The UVs here will actually work out kind of well if I model on top of this. But let's say there's some sort of a change here. Like, for example, we backpedal here, we move and sew those and unfold. Is there another way we could get that stretch section here? And there is. And I want to show you this because there are certain circumstances where this is going to need to be used, and we are going to encounter those, okay? So another method is if this doesn't unfold flat like what I showed you when we cut it, you can also double click the central cylinder here, and you can go to create and do a cylindrical projection. This is another option that will give you that cut down the middle. The one thing to be aware of though is there's often stretching, and we can check the stretching by turning on the UV checkerboard here. With the UV checkerboard on, what you want to see is perfect little squares, and you can see these are slightly rectangular. So with that said, we could use the scale tool to scale this out till they are rectangular, like so. You could also unfold if it will unfold correctly. It will not always do that, okay? So we're probably going to encounter that, but that is essentially the process. So when it comes to this setup here for a cylinder, there's a couple different methods that I use. So method one is going to be the manual method, and this is going to be where we do a camera-based projection. And then when it comes to the cylindrical shape, we're going to make essentially 3 cuts. This is going to be 1 cut for the lid, 1 cut for the base, and then 1 cut down the middle. And then after that, we're going to unfold. And the end result should be something like a circle, a square, and a circle for the top, bottom. Method 2 is very similar. It uses the same methods as method 1, where we're going to start with that camera based. Then we're going to make our cuts here, here, and potentially here. But when we unfold this, there's a chance that what we'll get is a circle and an arc and a circle. Now, this depends on the changes we've made to the object. So understand with a base cylinder, you're not going to get that. But sometimes you get this and that's undesirable. So what you will then do, if you have that, is you will go ahead and select the arc object across the middle, so the midsection, and then you can do a cylindrical projection and then adjust it as needed. So that is going to be the base process of projecting things that are cylindrical in nature. So understand this isn't just cylinders. This is going to be for things like the arm portion of a character. It can be things like tubing. It could be a lamp. There's all sorts of different things that take on the base form of a cylinder. Okay. Now, between cubes and cylinders, you get almost all of the objects you encounter in organic space and in hard surface space. So most objects are either a cube or a cylinder, but there is another one, which is going to be the sphere. And the sphere is actually a pretty tricky one at the end of the day. So when we talk about a sphere, what we're talking about is a circle with shading, if we're talking about it in two-dimensional space. Now, spheres can be used for a lot of different things. When we talk about spherical objects, one of the most common ones we run into when we talk about character art is going to be eyeballs. So eyes are often going to be spherical in nature and going to require specific UVs. There's other things we can encounter as well. For example, things like a planet. So if we had the planet Earth, I'll go ahead and just scribble Earth into existence here. If we had something like the planet Earth, then this would be something that would also be spherical. You can also have things like half spheres. So if we think things like doorknobs, this is often going to be a combination of shapes, and we'll tackle that when we get into our modeling. We need to break things down. So this one would be a cylinder for the handle, but it would be a half sphere for the front part here. So these come up every now and then, and they are pretty common, especially if you get into cartoony stuff. We have a lot of small things. If we go ahead and create a sphere here, create polygon primitives sphere, you'll see they have a very unique set of UVs where we have this sort of flat area here, and then we have these jagged edges. And for this particular object, I do want to show you an image on it. So I'm just going to assign a new material. We'll go ahead and grab a Lambert here. And we'll go ahead and input into here our prop desk reference here and open and hit 6. And you can see what's happening here is it's wrapping around the surface, and it almost looks like a fisheye lens that we're getting here, where it just nicely arcs across. And that's because what's happening here is that we have this nice and compacted across this flat surface. So there are circumstances where this is desirable for a sphere, but recognize what's happening here is we get a lot of this compression or really stretch, I guess we could consider it, but there's kind of a lot going on, a lot of distortion, and this makes it very hard to texture. So there's two methods for creating a sphere, depending on what it is you are producing. In some instances, like we used for the ball, this one can be okay, but this one tends to have a lot of distortion and can be harder to create, which is kind of interesting. So if you're working with a spherical object and you want to keep this style of UVs, my suggestion is try and preserve as much as possible. But let's take a look at how we might recreate these. The first step would be to edit and delete UVs to get rid of these. And the second step is likely going to be a spherical projection. If you come in here to create and you create spherical, you can see that spherical does a good job creating this spherical pattern on the inside for us to utilize. And you can see how that lays out nicely there. But similar to the cylinder, you can see the top portion here is questionable. These are converging to a singular point, a singular pole, and all these edges kind of sit at a bizarre angle. Not just that, they're kind of offset from our main area on our sphere. So what can we do about this? Well, the first thing is to identify them and then to slowly repair them. So what do I mean by that? If I take a look at this top section here, I can double click the edge here to select the edge loop, and I can cut these. Then to create the saw pattern that we had originally, I'm also going to have to come in here and cut each individual edge of these so we have individual slices. So I'm just going to hold down Tab there to select edges, and we'll cut. Then on this top section and just the top section and nothing else, I'm going to right-click into a component mode here. You could either use faces, UVs, or UV shells. It doesn't really matter. I'll go ahead and use faces since we're familiar with those. Highlight all of these and do a modify unfold. And what that will do is it'll unfold each of these. Then from here, we can double-click this edge, that is the top edge, and we can do a cut, move, and sew to move all these back into place. And that's the process. So if you want to recreate this on a spherical sort of object, that is how we can achieve that. It is a little bit of a pain, but there you go. So doing that again to the bottom, double-click the edge here. We can go ahead and cut. We can then come into here, into these faces. Once in, get into the edges with Tab here. Go ahead and cut. Select all of these and unfold. And then these ones are a little bit too large. I might select all the objects together and do a quick layout so they're the same size. And then just come along this space here and do a cut, move, and sew. And you'll notice a few of these popped out of line, so I would actually have to make some adjustments there manually. And we could do that using things like the components here, like the UV component. The UV component is a unique one. This is going to just affect the UVs as if they're vertices. It's different than vertices because vertices share a location. So for example, if I go into UV mode, you'll notice just that side selected and not the other. But if I go into vertex mode and select that, you'll see both sides are selected. So just be aware of that. In this case, I might actually consider that, and we could scale that outward there to flatten it. But you can see that's how we could recreate this. Now, this is not my preferred style for spheres. I don't use this style often. If I'm creating things like planets, I might consider this just because you can get a flat scan of them and you can often set them up this way so that they have a nice mapping to them. So if you think of something like the map of the Earth, this is kind of how we set it up, right? With the poles chopped up at the bottom and Earth kind of down the midsection. But what about for things like eyeballs, right? So if we were to try and map an eyeball to this, first off, we'd probably want to map the eyeball to here in this midsection where that circle is. That's going to cause some issues because now all of a sudden we have lines there and we have UV seams, and how are we going to account for that? So an easier way to do spheres, and the way that I prefer to do spheres, is just a split method, meaning we chop it in half in the direction we want. So let's say I was creating something like an eyeball. What I would do is I'd come in here to create. We'd go ahead and do a camera based. I'd find the midsection of the sphere here, double click, and do a cut. And then once you're done with that, that's the only cut you need to do. You can just do a modify unfold and then a modify layout. And what you end up with is these two halves. And if I turn on the stretching here, you'll see there's virtually no stretching. And this is a unique aspect. When you think about how those first ones were set up when we laid them down flat, there was nothing but stretching on those. So this gives us a nice, clean, and easy way to lay these out with minimal stretching. And if we're doing something like painting an eyeball, what we can do is we could come into here and we could obviously paint in our whites. I don't have a white color here, so I'll use yellow, but we could paint in our whites here, front and back of the eye. And then whichever side of this is the front, we could come in, and according to the number of rings in terms of size it needs to be, we could add in the eye color here. And then coming into the midsection, we could add in the pupil, and we know that's going to be mapped perfectly to that surface. So when you're thinking about spherical projections, you really want to think about, okay, how am I going to use this? Because, a default sphere to create something like an eyeball is not going to be fun. It's going to be very challenging. Whereas with something like this, you could very easily adjust it to your liking. Now, let's say we were building something like the robot. Would this be the method we'd want to use? You remember we had a little bit of issues with the face. It was kind of a challenge to get that on there. And the simple answer is yes, just we want to cut down the other axes. So rather than cutting it so that this circle here is facing the camera, we could come in and cut it the other way. So I could come in here and create camera based, but this time I could cut down the midsection of the circle. And we can have a front half and a back half. So I'll just go ahead and cut those. modify unfold, and then do a quick modify layout. And you'll see this way works as well. We do still get a little bit of distortion, but something like this is a lot easier to work with for something like a robot. For example, where the front is and where the back is clearly delineated versus what we had to deal with kind of guessing the exact place to place it, right? The other thing is because this is cut in halves, we know the exact center line. So we could just simply come into whichever sides are front. We could look at the corresponding faces, the amount of faces we want to have it take up, and straddle that across the midsection to get perfect symmetry. And there you go. We're done. Okay. So that's going to be the common methods for spheres. Is we're either going to take the sort of long approach, the default, I guess I'll call this one. And I don't use this one often. It's very rare. That's where you have a square with a lot of triangles. So the way we can do that is we can start with something like a spherical projection. We could then make some cuts. So we're going to cut the top portions. We're going to sew the top portions, and that's going to give us the end result. We might have to do other things like layout along the way, but then we will likely have to adjust those. So this one's pretty step heavy. The other method, which is kind of the option I use, I'll call this the I method just because that's the example I used. This one is very easy. You're just going to go ahead and do a camera-based projection. And then what that's going to give you is a sphere. Then what you're going to do is you're just going to cut in half. And it doesn't matter which half you choose. Then after that, you're just going to unfold. And then you're done. All right. Now, something to be aware of is spheres are anything spherical. So I have eyes, the earth, the doorknob here, right, for a half sphere. But when it comes to our character, we're going to have things like an egg. An egg could be considered a sphere. Other things that could be considered a sphere, believe it or not, are the tail. The tail can likely be considered a sphere because it has a rounded nature to it, as well as things like the claws. The claws are essentially an elongated sphere. And how could you judge that? You could ask yourselves, could I just take a sphere and with soft select pull it into this shape? And that's kind of a good way to think about it. The difference between a cylinder and a sphere is a cylinder has that flat top and that flat bottom, right? So your default thought for something like the tail would be like, well, the tail's a cylinder. And you're sort of right. It's a cylinder, but at one end you have a rounded top. So depending on how this is modeled, if it's modeled like this, where it has a clear cylindrical base, you could cut that and then do your midsection down and across to create a spherical projection. So that'd be like a cylindrical top and a sphere. But ours is more like this, where it has a rounded top and a rounded bottom. So there's really no reason to ever cut it this way. That would be incorrect. The only real sense you can make of it is just cutting down the circumference and getting a top and a bottom. Or you could cut it across the top, and we'll take a look at that when we get there. But that is going to be kind of the base idea, okay? So those are going to be the basic projection methods for tackling things. There's the spherical approach, which we just looked at, and then coming back into here, we have the cube approach with automatic, and then cylindrical, where you cut the top, mid, and bottom off, okay? So as a challenge, what I want you to do is I want you to do this exact exercise. I want you to go in there and create a cube, delete those UVs, and try using projection paired with the cut, move, sew, unfold tools to put that back together, and then repeat the process for a cylinder and then a sphere. And I encourage you to do both methods for a sphere. So now that we have those in place, what we're going to do is we're going to put these principles into action on our own objects, and we're going to start to create the final UVs that we are going to texture for those. All right. So go ahead and get that a shot to get used to the tools, and then join me in creating UVs for our official objects.